Here we go with chapter 2. So this first section we're going to be talking about integers. So starting off with the definition. An integer, highlight that real quick, is a whole number and their opposite, or would be whole numbers and their opposites. So we're talking about positives, negatives, and zeros. However, make a note, there are no decimals or fractions. So still no decimals or fractions. Just talking about our whole numbers and their opposites. Okay, so we want to write an integer for each situation, then identify its opposite and describe what it means. So part A, we have 23 degrees below 0. Below means we're going to be a negative, so negative 23. The opposite of negative 23 would be a positive 23. And in this situation, that positive 23 would mean 23 degrees Fahrenheit above 0. That's how we're positive. Okay, second situation, 11 inches more than normal. So more would be positive. So our opposite is negative 11. And our description would be 11 inches less than normal. Moving down to 1A, a loss of 8 yards. So loss would be a negative 8. So then positive 8 as the opposite. And then our description would be, for our positive 8, is a gain of 8 yards. And last one, a deposit of $15. So a deposit, if you don't know about banks, that's when you put the money into your account. So that makes your account gain money, so that's a positive 15. Opposite would be negative 15. And our description of the negative 15 would be a withdrawal of $15. So deposits, when you put the money in, withdrawal is where you take the money out. Okay, so there are some basic examples dealing with integers. Keep in mind, again, an integer is a whole number and its opposite, so positives, negatives, and zeros. When you have questions like this, please check directions. It was asking for 3 different answers. Okay, moving along. Any mathematical sentence containing a less than or greater than sign is called an inequality. So an inequality, let's squeeze that in the box there, compares numbers. So we're not talking about numbers that are equal anymore. They are comparing numbers or quantities. When 2 numbers are graphed on a number line, the number to the left is always less than the number to the right. So left is less. Keep that in mind. Use the integers graphed on the number line below in order to answer these questions down here. So write 2 inequalities involving 1 and negative 2. So if we go up here, we see 1 is right there, negative 2 is down there. So negative 2 is less than 1, or we could say that 1 is greater than negative 2. It asks for 2 inequalities, so you need to write it both ways. Notice when we flipped our numbers, we flipped our inequality sign. And you'll see this little hint over here for inequalities. The inequality symbol always points to the lesser number. So the further left on our number line, that's where our inequality symbol is pointing. So part B, replace the circle here with a less than, greater than, or equal to make a true sentence. So negative 4 and negative 6, if we come up to our number line, we see negative 4 here, negative 6 to the left of it. So that means that negative 4 is greater than negative 6. We could also read it as negative 6 is less than negative 4 if we read it backwards. Again, our inequality symbol is pointing at the smaller number. Then 2A, write 2 inequalities involving negative 7 and negative 3. Again, if you pop up here, negative 7 there, negative 3 here. So negative 7 is less than negative 3, or conversely, we could say negative 3 is greater than negative 7. And last one, again, replacing with a negative, or less than or greater than negative 1 and positive 2. Well, a negative, I don't care what these numbers are, a negative will always be less than a positive. So -1 is less than 2. Okay, so absolute values. Now that we know all about our integers, we want to talk about absolute values. So the absolute value of a number is the distance the number is from 0 on a number line. The absolute value of a number is always greater than 0, greater than or equal to 0. So highlight this if you can, greater than or equal to 0, meaning that it is always positive. We cannot have a negative absolute value. So when we look at this example, the absolute value of 6 and the absolute value of -6. On our number line, we see that -6 is right here, positive 6 is on the right, and we're counting to our 0. So 6 is 1, 2, 3, 4, 5, 6 units away from 0. -6 is also 1, 2, 3, 4, 5, 6 units away from 0. So the absolute value of 6 and the absolute value of -6 are both positive 6 because they are both 6 units from 0. Again, distance cannot be negative. Which, if you read down here at the bottom, notice on the number line that -6 and 6 are each 6 units from 0, even though they are on opposite sides of zeros. So the absolute value of a number line is the distance a number is from 0. So -6 and 6 have the same absolute value. Basically just recapping everything that I just said. Okay, so evaluating each expression. The absolute value of -4. So anytime we see these absolute value lines, I want to think about how far away from 0 on the number line is -4. Well, it is 4 units away. So our absolute value of -4 is 4. Then looking at part B, the absolute value of -8 minus the absolute value of 5. So the absolute value, take care of these first, of -8 is 8 minus the absolute value of 5 is 5. So 8 minus 5, final answer of 3. Please be careful, you are not just changing your sign. Absolute value, again, is always, always, always positive. -8 is 8 units away from 0. 5 is 5 units away from 0. So that's how we got our 8 minus 5 to be 3. Then evaluate 6 plus the absolute value of x if x equals -2. If you remember from the last chapter, first step is always to show our substitution. So 6 plus the absolute value of -2. Take care of this absolute value. Make sure your absolute value lines are long enough, by the way. Make sure it doesn't look like 121. So 6 plus absolute value of -2. -2 is 2 units away from 0, so plus 2. So you get a final answer of 8. And one more like this. Evaluate 9 minus 5 times the absolute value of z if z equals 3. So substituting in first, 9 minus 5 times the absolute value of 3. We're multiplying here since they're right next to each other. So 9 minus 5, take away that absolute value. It is 3. Again, make sure you show some kind of multiplication symbol there. It's not 53. According to our order operations, multiplication comes before subtraction, so 9 minus 15. And if you guys are not used to working with negatives yet, don't worry about it. That's coming up in later lessons. Just know that our answer is -6. Okay, so our next example. Evaluate each side, then determine which symbol makes the statement true. Write your symbol in the box. Okay, so again, if you're not used to your negatives yet, I'm not sure what you guys worked with last year, just follow along. Know that we will work with our negatives in later sections. -16 times 2 gives us a -32. So this side is done, our left side's done. Over on the right side, taking care of the numerator first, -2 times 15 is -30 over 3, which we know fractions mean division, so -30 divided by 3 is -10. So -32, how does that compare to -10? Well, if you think about our number line, if our 0 is here, I count by tens, -5, -10, -15, -20, etc., etc. And you see our -10 is here. Continuing somewhere down here is our -32. So negative 32 is to the left of negative 10, so that is going to be less than. So final answer in the box, less than. And last one, what is the value of AB minus the absolute value of C if A equals 14, B equals negative 2, and C equals negative 8? You guys can kind of go down into the bottom of the page if you need to, depending on how big you write. So substitution first, 14 times negative 2 minus the absolute value of negative 8. Make sure you put this in parentheses because of the negative. 14 times negative 2 gives us a negative 28 minus the absolute value of negative 8. Go ahead and take care of its absolute value. So negative 28 minus 8, which would give us a negative 36. Again, don't worry if you're not sure about the negatives. Okay, so that is the end of this lesson other than the Now You Try. So there's a couple of them here for you. So in this first example, I want you to give us our less than, greater than, or equal symbol. Please write out the whole statement. So negative 35, fill in a symbol. How does negative 35 relate to 12? And then last up, evaluate the expression if A equals negative 3, B equals 0, and C equals 1. So C plus the absolute value of negative 5, you only need the C. There is no A or B. So go ahead and write down that problem, show your steps, including your substitution. Okay, so this was a bit of a longer lesson to start the chapter, but hopefully you followed everything. And we are done. Pause that until you're done with the Now You Try, and we'll check them out tomorrow.